couple of these examples in the way that I learned them in high school. The conceptual process is the same as what you learned in the YouTube videos, but my process is a little bit different. And of course, it works for me because I'm a visual person. And as you will see, the process is a little bit more visual, like I have to draw boxes and stuff. So as you can see, this is a polynomial of the form ax squared plus bx plus c. So for this particular polynomial, we know that our a is 1, our b is 7, and our c is 6. Okay, a, right, that's our invisible coefficient of 1, b, and c. So when I do this, I actually draw a box like this. And in this first section, I put my first term. So I'll put x squared here. I put my last term in this bottom right-hand box. So that would be 6. And then in these two boxes, I put the factors of 6 that when added together give me my middle term. So I know that my factors of 6, right, 6 we could break down into 6 times 1. We could also do that as 3 times 2, right? But I'm looking for the factors that will give us 7. So I'm going to choose these first two factors. So if we have 6 and 1, I know that 6 plus 1 equals 7. So 6 plus 1 equals 7. So here I'll have a 6x plus 1x. Then I factor out each of my rows and columns like that. So here, what can I pull out of x squared and x? What can I pull out of both of those terms? Well, I can pull out just an x. That's the only factor that they have in common. I can pull out 1x from here, and I can pull out 1x from here, and that's it. What can I pull out of 6x and 6? Well, I can pull a 6 out of both of those. What can I pull out of x squared and x? What do they have in common? Well, the only thing they have in common is, again, an x. What can I pull out of 1x and 6? Well, I can pull out just a 1. So now these are my factors. We have, at the top, we have x plus 6. That would be my first factor. And my second factor is here, x plus 1. Okay, so my final answer would be this, okay? And you can always double check this by multiplying, right? X times x is x squared. Then we have a 1x plus 6x, which will give us 7, and then 6 times 1 will give us 6. Okay, so this is your final answer. That is how you would factor these. These would be the factors. X plus 6 and x plus 1 would be the factors of this polynomial. So let's look at another example similar to this one. So here in this example, still we're in the form ax squared plus bx plus c. In this particular example, again, our a is 1, our b is 9, and our c is 8. Okay, so again, I'm going to start off with my box. All right, I'm going to put my first term in the upper left-hand corner, x squared. My last term in the bottom right-hand corner, that's 8. And then I'm looking for the factors of 8 that when added together give us 9. So again, we have 8 times 1, 4 times 2, and we can stop there. I can clearly see that 8 and 1, when added together, will give us 9. Okay, and actually you want to remember that if this second operation is plus, then the signs have to be the same. If the second operation is a minus, then the signs of these two boxes will have to be different. And we'll see that eventually. So we know that 8 plus 1 equals 9. So here I'm going to have an 8x and a 1x. And then I'm just going to pull out my factors from each row and column. So in common of x squared and x, I can pull out an x. From here, I can pull out an 8. From here, I can pull out an x. They have an x in common. And from here, I can pull out a 1. So again, here are my factors, x plus 8 and x plus 1. X plus 8 and x plus 1. That would be how I would factor this polynomial expression. Let's look at another example where a does not equal 1. So here's an example where a does not equal 1. So let's actually identify what a, b, and c are here. Well, we have our a, b, and c. So in this particular example, our a is equal to 2, our b is equal to -5, and our c is equal to -7. So again, I'm going to start off with my box. Okay. Now, again, as I mentioned, we're looking at this last sign. It's a minus, so I know that the signs in these two boxes are going to have to be different. Now, the trick here is that in order to figure out what number I am looking at to find the sum of, I need to multiply this first and this last term, or the coefficients of the first and the last term. So I'm actually looking at the number 14 here because 7 times 2 is 14. And I want to figure out what factors of 14 give me 5. So let's take a look at that. Let me use green. So we have 7 times 2 equals 14. And let's look at some factors of 14. So we have 14 and 1. We have 7 and 2. And I think that's it, right? Yep, those are it. So I'm looking at which of these factors will give me 5. Well, I can see here, right? 7 and 2 can somehow give me 5, right? And actually we're looking for a -5. So I know that 2 minus 7 gives me -5. So here's what we write. We put our first term in our upper left-hand box, 2x squared. Our last term in our lower right-hand box, -7. And then I use what we just did here to determine the values that go in these two boxes. So I know that positive 2x minus 7x will give me -5x, right? Because positive 2 minus 7 will give us -5. Then I pull out my terms and change to red. So out of out of 2x squared and 2x, I can pull out a 2x from both of those. Out of -7x and -7, I can pull out a -7 from both of those. Out of 2x squared and -7x, I can pull out just an x from both of those. They don't have any other factors in common. And out of 2x and -7, they don't have anything in common, so the only common factor they would have is 1. So here we have our factors, x plus 1 and 2x minus 7, okay? And you're always going to want to double check these. I'm going to write this one first just because it has a larger coefficient, and it's typically how we write them. X minus 7 and x plus 1. So I know that I did something right, because this minus sign here leads me to know that the signs in our factors have to be different. I'm just going to double check. So if I double check this, let's do that in yellow. Okay, we have 2x times x, that'll give us 2x squared. 2x times 1 will give us 2x. And then start with the second one. So -7 times x will give us -7x. And -7 plus 1 times +1 will give us -7. And then we can combine the middle two terms to give us positive 2x, minus. I'm just double checking that I did this right because I did not do these beforehand. So I ended up getting what we started with, right? That is equal to that. So we know that this factorization is correct. Okay, so our factors would be 2x minus 7 and x plus 1. One more example like that. So in this particular example, our a is equal to 5, our b is equal to 15, and our c is equal to 10. So this is an example where there would actually just be one more step. It's optional, but it's helpful. So using the method that I just did in the previous example, normally we would multiply our last term and our first coefficient to determine what number we need to find the factors of. But because all of these coefficients have, or your A, B, and C have something in common, we can actually pull something out of this entire expression first. That'll make it just a little bit easier. So we can actually pull a 5 out of each of these terms. So I can pull a 5 out of these terms, and then we, in our parentheses, we would have 5 times x squared would give us 5x. And then we could pull a 5 out of our middle term. That'll give us 3x, because 5 times 3x gives us 15x. And then 5 times what gives us 10? Well, 5 times 2 gives us 10. Okay, plus 2. So hopefully that's easy. And if you were to redistribute that 5 to each of these terms using the distributive property, you would end up with this first expression. So these two expressions are equivalent, but this makes it a little bit easier because now you don't have to find the factors of 50, right? You just have to find the factors of, well, 2 times 1, which is actually super easy. Okay, and this 5 doesn't go anywhere. This 5 stays here. You're factoring what's on the inside now. So on the inside, okay, we want to factor x squared plus 3x plus 2. So again, I'm going to start with my box. Okay, and I'm going to put my first term in the upper left-hand corner, last term in the bottom right-hand corner, and then I'm determining, because 2 times 1 is 2, so the number that we want to look at is 2, and we know the only factors of 2 are just 2 and 1. So how can I use 2 and 1 to get to this middle number? Well, 2 plus 1 equals 3. So we're going to have a positive 2x and a positive 1x, and then we're just going to pull the common factors out of each of our rows and columns. We have an x here, a 2 here. I can pull a 2 out of both 2x and 2. And then we would have an x here and a 1 here. Okay, so our factors are x plus 2 and x plus 1. So this would look like x plus 2, x plus 1. Okay, you can always double check that. Before I double check, I know that this last operation, or the second operation of my polynomial, is a plus, so the signs on the inside of my factors have to be the same, and I see that that is true, so I know I'm on the right track. And then we can't forget that 5 didn't go anywhere, right? So the actual whole factorization of this whole thing would be this, including that 5. Okay. Yeah, and you would get the same thing if you were to factor this whole thing the same way using 50 instead of 2, but obviously 50 has a lot more factors than 2, so factoring out this 5 as your first step helps to make this a lot easier. The last thing that I want to note is that not all polynomials are factorable. So if you go through this process and it does not work, chances are that the polynomial is not able to be factored. So hopefully this strategy helps some of you guys. If you would like to use the strategy that you learned in the videos, please feel free to do that. Both of them will get you to the correct answer.